Given f of x equal to 2x cubed minus 2x squared plus 4x minus 1, determine the interval on which f is concave up. Alright, first, terminology. Concave up. This means where our graph, for example, if we had the following graph that went like this. Concave up is this area over here. Concave down would be this area over here, separated by these points, namely the inflection points. Alright, so to put it into simple terms, they want us to give the x interval, so for what x is, this function is namely concave up. So list all the x's where if we plotted this function, our graph would be concave up. So little bit confusing because now we're going to be dealing with derivatives, and each derivative's graph looks a bit different to its integral of that graph. I'm not going to talk about integration. Each derivative looks a bit different. Its graph, the double derivative looks different when you plot that graph to the single derivative, the first derivative, I mean. But really, if you just learn a little bit of theory, go into Desmos, go into a graphing calculator, so that you can visualize, not in the test, but beforehand, so you can visualize what you're doing. These questions really aren't that bad, and you'll be fine. So some theory we're going to have to learn is when they want to show the interval for where this graph is concave up, we must know that the second derivative of this graph, it will be all the x's of this function bigger than 0. If they wanted where the graph was concave down, we would be solving for all x's of the second derivative where it is smaller than 0. Some theory we're just going to have to learn. Not too difficult to remember. Also, I highly recommend take this graph, plot it on a graphing software online or something, then find its derivative, plot that graph, then find its second derivative and plot that graph. It will be so much easier if you go and just visualize what we're doing and to see how they look compared to one another. Highly recommend you do that. So we're going to be solving for the x's where f dash dash is bigger than 0. So let's do that. So first we need f dash. So f dash will be 6x squared minus 4x plus 4. F dash dash x will be equal to 12x minus 4. So now we have our f dash dash. Now we're going to just solve this inequality. 12x minus 4, where for what x's is this expression bigger than 0? Take the 4 to the other side. We're dividing by a positive, so we don't need to flip the sign. If we were dividing by a negative, we would have to flip the sign. We don't need to here. 4 over 12. That's just another way of saying, oops, 1/3. So a nice easy inequality. Didn't have any, for example, didn't have a interval. Say, for example, this x and this x. Was no intervals. It was a nice easy inequality we had to solve. Namely, it's all x's bigger than 1/3. So what we've shown is if we were to plot this graph, for all x's greater than 1/3, our graph would be concave up. And that's very useful information, and it was easy to acquire by using first and second derivatives. And that's all we had to do. That is the question solved.